Yesterday we looked at systems of linear equations, and today we're going to look at how we can solve them with substitution and elimination. Let's look at this same problem we did yesterday. What we could do is write two equations for members and non-members to set up our system. So members have a fee of $28 and they pay $2 per game. So that's $2 for every game plus $28. Non-members just pay $6 per game, no fee. When you have two equations in slope-intercept form, you can use substitution pretty easily. Substitution means that we're going to substitute a value for a variable. Since y equals 6x, we can substitute that value in for y in the other equation. To set this up, instead of a y, we'll write 6x, and then we still have the rest of the equation over here. We're just substituting that value. Now we can solve like we have done before with variables on both sides. Divide by 4. Remember what x means? It means the number of games. So 7 is the number of games that will cost the same for members and non-members. Remember, when you're solving a system, you usually will have an ordered pair unless they ask for a specific value or the question says one thing to find. But otherwise, we're looking for an ordered pair. So to find our y value, we need to plug this 7 back in to one of these equations. It doesn't matter which one, so typically I pick the simplest equation. So the system's solution is 742, which matches what we found yesterday using a table of values. Let's look at this system. One of the equations is in slope-intercept form and the other one is in standard, but we can still use substitution. As long as you have one variable isolated, substitution works really well. So y equals 1/2 x plus 5, so we're going to substitute that value in for y in the other equation. Be sure you carefully copy every other part of the equation. You don't want to leave anything out. So this gets put in for y, but everything else remains the same. Now we just start simplifying and solving. Start out by distributing. 4 times 1/2 x is 2x. 4 times 5 is 20. Now we'll combine like terms. Then we'll use inverses. So x is 4. In order to find our y value, we need to plug this back in either equation. It doesn't matter which one, you should get the same answer. I'm going to plug a 4 into this second equation. 1/2 of 4 is 2. 2 plus 5 is 7. So the final solution here is 4, 7. Let's look at this system. These are both in standard form. If I wanted to use substitution, I would need to isolate one of these variables. Or I can use elimination. So let's walk through what elimination is and why it works. I'm going to take this first equation, 4x plus 8y equals 12. Now remember, this equal sign means that these two sides are balanced. So whatever I do over here, I need to do to this side. What if I want to add 5x minus 8y to this side? I want to add it to this whole side. In order to keep this equation balanced, I would need to do that on the other side as well. However, if I look back up here, 105 is equal to 5x minus 8y. So I can keep this balanced by adding 105 to this side. So I'm basically going to add these two equations together. and let's see what happens. 4x plus 5x is 9x. 8y and a negative 8y, those cancel. And 12 plus 105 is 117. And then I can solve this. 9 goes into 117 13 times. Now to find my y value, I'll plug 13 back in either one of these equations. Let's use the first one. 4 times 13 is 52. Now I'll subtract 52 from both sides. Divide by 8, and y is negative 5. So my solution is 13, negative 5, using elimination. Remember, if I were to graph these two equations, they would intersect at one point, and that one point would be at 13, negative 5. If I plug 13 in for x and negative 5 for y, it will work in both of those equations. Let's look at this system. Both equations are in standard form, so elimination is probably going to be my best method. But if I just start adding right now, nothing will be eliminated. I'll still have x's, I'll still have y's. So it won't help me any. What I need to do is transform one of these equations so that when I add them together, one of the variables is eliminated. Now you can do this in different ways, but it's best to look for friendly numbers like 8 and 4. I know if I double this 4, then I'll have a match here, but I also need them to have different signs. So if I multiply this second equation by negative 2, then I'll have an opposite here. So let's do that. This whole equation will get multiplied by negative 2. Negative 2 times 4x is negative 8x. Negative 2 times negative 7y is a positive 14y. And a negative 2 times negative 44 is 88. We'll keep the first equation just like it is. Now I can just add these equations together and hope that one of the variables is eliminated. 8x minus 8x, those cancel. Negative 2y and a positive 14y. 12y, negative 16 and a positive 88. When I combine those, I get 72. Then I can solve by dividing by 12, and y equals 6. In order to find my x value, I plug this in for y in either equation. Let's use the first one. Negative 2 times 6 is negative 12. Add 12 to both sides. Divide by 8. And x equals negative 1/2 or negative 5/10. So my solution here is negative 0.56. And I can plug this point back in either equation to make sure it is true. Here are a couple things to look out for. What if you're solving a system of equations? In this case, we'll use substitution since the variables are isolated. And you end up with something like this. Remember when we solved equations, we said this wasn't possible. That is still a no solution. If you were to think about what these lines look like on a graph, they have the same slope but different y-intercepts. Those are parallel. They'll never intersect, and that's why they have no solution. What if you have two systems and you're using elimination, and let's say we take this first one and we want to multiply it by negative 2, so that I'll get negative 4x minus 6y equals negative 10, and then I'll bring down my other equation. And when I go to add them together, those cancel, those cancel. 10 minus 10 is 0. Does 0 equal 0? Well, it does. This is not a no solution. This is an infinitely many solutions. If we were to graph both of those lines, they would be the same line. So they share lots of points in common, and that's why they have infinitely many solutions.